Everything you can see and touch, the device in your hand, the chair you're sitting on, even the air you're breathing right now, it's all built from the same tiny fundamental building blocks. So today, we're going to take a journey deep inside one of them, the atom, and really get to know its incredible architecture. Seriously, just look at your desk for a second, or your hand. What is it really made of? I mean, really, if we could zoom in like a billion times, you wouldn't see wood or skin or plastic. Nope. You'd see this bustling little universe of tiny vibrating structures. You'd see atoms.
So, what are these atoms actually made of? Well, it all boils down to just three. Three key players. Think of them as the main characters in this story. We've got the proton, the neutron, and the electron. If you can get your head around these three, you'll basically understand the foundation of, well, everything.
All right, first up, let's talk about the basic blueprint. Because here's the cool part. Every single atom in the universe, I'm talking from the simplest hydrogen to the most complex uranium, follows the exact same two-part design. It's actually pretty simple, but it's super powerful. You've got this super dense, really heavy center called the nucleus, and then, buzzing all around it, you have this kind of wispy, energetic region called the electron cloud. So just picture a heavy core with this lightweight cloud zipping around it. That's the basic model for every atom. Okay, so now let's zoom right into that core, into the nucleus. This is where we're going to find the two heavyweights of the atom. First up, meet the proton. Its home is right there in the nucleus. Now, there are two really crucial things you need to know about it. First, its charge is positive, and second, its mass. We measure this stuff in what's called an atomic mass unit, or AMU for short. The proton weighs in at exactly 1 AMU. So yeah, it's one of our heavy lifters, for sure. But here's the proton's most important job. This is the big one. The number of protons in an atom is like its unique fingerprint. It's called the atomic number, and it is the one thing that defines what element you're looking at. And here's the key. For any given element, that number never ever changes. For example, if you find an atom and it has exactly one proton, it is always hydrogen. Period. No exceptions. It doesn't matter what else is going on with that atom, that one proton is its non-negotiable ID card. And how about this one? If you find an atom with 6 protons, it is always carbon. Think about that. From a diamond to the carbon dioxide you just exhaled, every single one of those carbon atoms has exactly 6 protons. That's its unique identifier. That's what makes it carbon. Okay, so now let's meet the proton's roommate in the nucleus, the neutron. And just like its name sounds, it's neutral, no charge at all. Zilch. It has pretty much the same mass as a proton, so it's our other heavyweight. And its job? Oh, it's crucial. It adds mass, yeah, but it also acts like a kind of nuclear glue, keeping all those positive protons from pushing each other away and just flying apart. All right, so we've explored the dense center. Now let's zoom back out and take a look at that buzzing cloud on the outside. It's time to meet our third and final particle, the super-energetic electron. So the electron lives out in that cloud, way outside the nucleus. Its main thing is its charge. It's negative, which is the perfect opposite of the proton's positive charge. But what about its mass? Well, it's so tiny that we pretty much consider it zero. I mean, to put it into perspective for you, it would take almost 2,000 electrons just to equal the mass of one single proton. They're incredibly lightweight. And this right here is such a crucial point. If the protons give an atom its identity, telling us if it's carbon or hydrogen, then the electrons give it its personality. They are the social butterflies of the atomic world. They're responsible for all the interesting stuff, chemical reactions, atoms bonding together to make molecules, even the flow of electricity. It all comes down to what the electrons are doing. And there's this simple, really elegant rule that keeps everything stable. For an atom to be neutral, which means having no overall charge, those positive protons have to be perfectly balanced out by the negative electrons. So what does that mean? It means in any neutral atom, the number of electrons you find orbiting the outside is exactly equal to the number of protons packed in the center. All right, so we've met our three main characters, the proton, the neutron, and the electron. Let's put it all together now and see how their properties create the atom's complete identity code. So what about an atom's weight, its atomic mass? How do we figure that out? It's actually a super simple recipe. Since only the particles in the nucleus have any real mass, you just count the heavyweights. You count up the protons, you count up the neutrons, and you just add them together. That's it. And what about the electrons? We just ignore them for this calculation because they're simply too light to make any real difference.
And here it is. This is basically the ultimate cheat sheet. It puts everything we've talked about in one spot. You've got the proton, giving the atom its identity, the neutron, adding mass and stability, and the electron, controlling its chemical personality and all the reactions. Seriously, if you can master this table, you've totally mastered the basics of the atom.